Hello. Today we're going to have a look at the area of special quadrilaterals. Now we're going to have a look at four specific shapes. We're going to have a look at parallelograms, trapeziums, rhombuses, and kites. Okay, so each of these you could actually use all the knowledge that you learned in last lesson when you did the composite shapes by breaking them into separate shapes. But however, we can develop formulas to actually calculate the area of each. So let's go through a few and how they come about. So the very first one here, I've got a parallelogram. So that's up the top here. So what I can actually do is here, I can cut this along here, okay, exactly along here. Now, if I were to cut this out and actually paste it in here, this will form a perfect rectangle. And it will have the same length as this top part up here. Let's call that A. Okay, so this is A. Okay, and then I'll have this same perpendicular height here. Let's call that B. Okay, so B is the distance here. Okay, so because I have a perfect rectangle, I can say, well, it's going to be the same formula as a rectangle, A times B, the width times the height. So here, it's just going to be those two multiplied together. So make sure you write that down. Now let's have a quick look at trapeziums. Now there's a few ways to do this. So here I've got, for a trapezium, it has to have one set of parallel sides, which you can tell here by the two arrows. Now you can do this by the composite shapes of, well, bringing the rectangle down to the bottom there, okay, and then you could actually bring the two triangles together to make one triangle. So that's one way on how you can calculate this. However, what you could also do is if you actually cut halfway, exactly halfway between here and here, this part here, and put it up here, okay, you're actually going to get, well, that will start to be like sort of like the corner of a rectangle. And if I do the same thing here, so I'm putting this part here, okay, then I'm actually going to get a perfect rectangle. Okay, with a length exactly between here and here. So to do that, if this top part here was A in length, and this part down the bottom here was B, okay, then the extra length here, okay, will be exactly in between A and B. So we could say that the length here to here, okay, will be A plus B over 2. Now, we will still have this perpendicular height h, okay? So this side here will be h. So what I can do for the formula, I could say, well, it's going to be h times a plus b over 2. So therefore, the formula here would be h over 2 a plus b. All right, so let's make sure that we copy that formula down. Now, if you are finding this confusing, and that's perfectly fine, just make sure that you get these formulas down and we can revisit this video at a later time when you have a better understanding of area. Okay, so sort of the strategy that we're doing is actually getting these into rectangles. Okay, and we're sort of going to have a bit of a look similarly with rhombuses and kites. It's the same sort of process. We need to try and find this bigger rectangle and see how the shape relates. So here what I'm actually going to do for the rhombus, okay, I'm actually going to extend each of the corners to get an exact same triangle. So this triangle here, 1, will be the same as 2. This one here of 3 will be the same as 4. Apologies about my lines, okay. I know I probably should be using a ruler, okay, so this will be number 5, and this would be 6, this will be 7, and this will be 8. So this is technically in eighths. Now, the rhombus is actually making up 4 eighths, okay? 4 eighths, which we know is a half. So it's actually going to be a half of this bigger rectangle, okay? So the area of the larger rectangle will be x times y, but then I know the rhombus is only half of that, so I'm actually going to divide that by 2. So the formula for a rhombus is x times y over 2. Okay, so make sure you copy that down. Similarly, we're going to have a look here at the kite. Okay, so you could do this in 2 separate rectangles, or we could look at the overall one. Okay, because the triangles are separate, but 1 will match 2. Okay, so half of it's outside the kite. 3 will match 4. 5 will match 6. And 7 will match 8. So once again, I have 4 eighths here, so the kite is only half of the total area of this larger rectangle, x, y. So here the area would then be 1/2 times x times y, which would be xy divided by 2. So it's actually the same formula as a rhombus, okay? It's the same. Now let's go and have a look at some of these actual examples and work with a few numbers. Okay, so here we have a parallelogram. So here I can tell that the perpendicular height, the height with the 90 degrees here, is actually going to be 5 meters, and it's multiplied by a base of 10 meters. So 10 meters up here will be the same. Okay, and remember we're sort of putting this over here to create a rectangle. Okay, so our formula here, okay, is actually going to be the A is equal to xy, which would be 5 times 10, which is 50 meters squared. Okay, so here we're looking at units, and we need to make sure that we have squared. Let's have a look at this second one here. Now here, this is a trapezium, okay? It should have one set of parallel sides, which are these ones, okay? Now there's a few ways to do it. You could turn it into a composite shape, okay, and go about it that way, or we could actually use the formula. So the formula is A is equal to the height over 2 multiplied by the sum of A and B. So here this is A, and this is B, and this will be the height. So let's put each of these into the formula. Okay, so I'm going to have, well, A will equal to H, which is 6, over 2, times by A, which here is 4, plus 10. So here, 6 over 2 will be 3 times, in the brackets here I do bid maths, 4 plus 10 is 14. Okay, 3 times 10 is 30, and 3 times 4 is 12, so this would be 42 millimeters squared. Okay, last one now. So here we go, we got a kite, okay, and that's because adjacent sides here are equal, okay, but not all sides are equal, because these aren't equal to the ones above, so that's how I can tell it's a kite. But these two adjacent, which are next to each other, are equal. Now the formula here is x times y over 2, okay, where x is 8 and y is 12. So let's put these in the formula. So I have A, the area, is equal to x, which is 8, multiplied by y, which is 12. over 2. Okay, so let's do the top. So that's 96 divided by 2, which will equal to 48, and the units are centimeters squared. Fantastic. Okay, guys, so make sure that you have all of those formulas written down into your exercise books. And if you have any questions, please just comment or ask your teacher. Thank you.